example 3, we're going to solve equations using determinants. So we're finding the values of x that give the stated value for the determinant. So in A, we have a matrix with a first row of x, then 2, a second row of 8, then x, and we want the determinant to equal 0. So if we set this up by finding the determinant, multiply our first diagonal minus multiply our second diagonal, x times x minus 8 times 2, we want that to equal 0. Well, x times x is x squared. 2 times 8 is 16, so we have x squared minus 16 equals 0. This is a quadratic equation. And since there's no linear term, we can solve this by isolating the x squared and then using the square root property. So if we add 16 to both sides, we have x squared equals 16, and then if we take the square root, x equals positive and negative 4. For example B, this time the first row of our matrix is x plus 1 and then negative 8. The second row of our matrix is 3, then x minus 4, and we want the determinant to equal 30. So if we set this up as an equation by finding the determinant, so multiply our first diagonal, x plus 1 times x minus 4, minus multiply our second diagonal, negative 8 times 3, we want that to equal 30. Now when you multiply the x plus 1 times the x minus 4, you can either do the double distribute, or you could use a box and multiply out all the pieces. X times x is x squared, x times negative 4 is negative 4x, 1 times x is 1x, 1 times negative 4 is negative 4, minus negative 8 times 3 gives us negative 24, and that's all equal to 30. Now if we combine some of our like terms, negative 4x plus 1x is negative 3x. When we subtract negative 24, remember it's going to be like adding 24, so negative 4 plus 24 gives us 20. X squared minus 3x plus 20 is equal to 30. Now, this time we have a quadratic term and a linear term, so we can't use the trick that we used over here with the square root property. We're going to need to get one side to equal 0 and solve this by factoring, or you could use the quadratic formula for those of you that are big quadratic formula fans. So to get one side to equal 0, I'm going to subtract 30 from both sides. So now I have x squared minus 3x minus 10 is equal to 0. And to factor this, we need a pair of numbers that multiplies to give negative 10 and adds to give negative 3. That would be negative 5 and positive 2. So our factors, x minus 5 and x plus 2 equals 0. If you set each factor equal to 0, then you can solve to get x equals 5 and x equals negative 2. Your assignment for this section you can do on WebAssign or on page 575, numbers 33 to 35, and on page 582, numbers 8 to 16, 20, 82, 84, and 86. The next two slides I'm not going to narrate, but they do offer some enrichment activities for those of you that are looking for a little more challenge in this section. Please feel free to check them out and let me know how they go. The first challenge is looking at determinants with larger matrices. You can pause and take a look at everything that's on the screen and attempt the activity. And then the last one is trying to discover some properties of determinants. Again, you can pause the video or look at the presentation that's posted on Google Classroom and spend some time working through these. Good luck, and let me know if I can assist you in any way.